Chapter 9, Objective 1. Due to repulsion theory, electrons spread themselves out. For example, nitrogen has 5 valence electrons. You can notice there's a non-bonding pair. Therefore, only 3 of the electron domains can actually bond. Now we will show the Lewis structure for NH3. The geometrical shape for NH3 is called trigonal pyramidal. Non-bonding electron domains have a stronger repulsion force because there are 2 of them, and bonding electron domains only have 1. This might be how you expect H2O to be drawn. However, the repulsion forces of the non-bonding electron domains cause the molecule to be bent like this. If you want to figure out the geometrical shape of a molecule, you'll have to use something called the VSEPR model. If you want a linear geometrical shape, you have to have 2 bonding domains along with 0 non-bonding domains, such as CO2. To have a trigonal planar geometrical shape, you have to have 3 bonding domains with 0 non-bonding domains, such as boron trifluoride. There is also a bent version of this geometrical shape. It has 2 bonding domains and 1 non-bonding domain, such as nitrogen dioxide. The last shape in the VSEPR model chart is a tetrahedral. It has 4 bonding domains with 0 non-bonding domains, such as CH4 or methane. There is also a trigonal pyramidal with 3 bonding domains, 1 non-bonding domain known as NH3 ammonia. There is also a bent version of trigonal pyramidal. It has 2 bonding domains with 2 non-bonding domains, such as H2O. If you want to know if something's polar or not, you could use this chart of electronegative charges of some atoms from the periodic table. Less than 0.5 is nonpolar, greater than 2 is ionic, and in between the 2 is polar. For example, HF, in the molecule HF, F would have a charge of 4 minus 2.0 for H, and the difference of that would be 1.9, making the molecule polar. There is also another way to tell the polarity of a molecule. We can analyze the magnitude and the direction of bonds. For example, in boron trifluoride, boron is the central atom. It has an exception to the octet rule, so it doesn't require 8 to fill an octet. The fluorides are attached and all pulling equally because they have the same electronegative charges. Therefore, the dipoles would cancel each other out and make the molecule nonpolar.